So in this video, I'm going to walk you through the steps for balancing equations. So if you already are familiar with this, you can kind of fast forward through and see if there's anything that you need to pick up on. There'll be some examples. Otherwise, I'm going to go ahead and get started. So first thing, if the equation is going to be given to you in words, you want to write it into a formula with reactants and products. So, for example, get something like this. Natural gas, which is carbon and 4 hydrogens, which if I would give this to you in words, I would give you a formula that you wouldn't know. So I wouldn't ask you to know that is natural gas, that natural gas is made out of methane. So it burns by reacting with oxygen, and it's going to produce carbon dioxide and water vapor. Now, I don't give you the formulas for these other guys because these are ones that I would expect you to know the formulas for, just because they're common chemicals that keep coming up. So we've seen oxygen, that's O2, carbon dioxide, CO2, water vapor, H2O, okay? So you write the equation out because it says that it burns by reacting with oxygen. That tells you that these guys are the reactants. So they go on that side of the arrow. And then produce, so those are the products, carbon dioxide and water. So we've got our equation. Sometimes you'll just have the equation, and that will let you keep going. So now, inventory the number of each kind of atom on both sides of the equation. So you want to take a look and see how many you have of each atom on each side. Is there an imbalance? Do they not equal? Then yes, keep going. If they're equal, then you're done. You don't need to balance anything. So let's take a look here. So we've got carbon. This is how I always keep track. We've got hydrogen, and we've got oxygen. So when I ever do one of these, at least when I started working on them, this is how I would do it. I would make a list and say, okay, so I've got carbon. On this side, I've got 1. Hydrogen, I've got 4. And oxygen, I've got 2. On the other side of the equation, carbon, I have 1. Hydrogen, I have 2. And oxygen, I've got 2 here plus 1 here. So I've got 3. So you can see the numbers don't equal. We have the same number of carbons, but the oxygens and the hydrogens don't match. So we have to keep going. So now we need to figure out where to put the coefficients, those big numbers in front of the formulas to start balancing the equation. And remember that those coefficients apply to all the elements in the compound that it's placed in front of. So if you put a 2 in front of CO2, so if we've got 2 CO2, then that means you've got 2 carbons and 4 oxygens, because it's 2 times the 2, okay? So there's another example. So for 2H2O, you've got 2 times 2, so 4 hydrogen, and 2 times 1, 2 oxygen. All right. So we need to figure out where to put different coefficients. Sometimes it's just a guessing game. And so you keep doing 2 and 3 until you get all of the atoms that are equal on both sides of the equation. So we've got this one with methane. I went ahead and balanced it. So let's see if it is actually balanced. So we knew that the carbons were equal, but we knew that the hydrogens and the oxygens weren't. So when I went to balance it, I decided I'd try to balance the oxygens first. So I went ahead and did this one. So I said, okay, let's put a 2 here in front of the oxygen. So now on this side, we've got C, H, and O. So we've got 1 carbon, 4 hydrogens, and now 4 oxygens. Okay. So if we put a 2 here, that makes it 4 oxygens. So I need to do something to change the number over here. I also could have gone for the hydrogens first, which I know I need 4 hydrogens. So I could have made the 4 hydrogens there. So we look now by putting a 2 in front of the water. We've got 1 carbon. We've got, for oxygen, we've got 2. And because I put the 2 there, that makes 2 here. That's why I decided to do the oxygen first. So 2, and that makes that 4. And then 2 times 2 makes 4 hydrogen. Okay. So that gives us a balanced equation for this one. So let's take a look at some other examples. So here is aluminum oxide. I saw this in another video. And it is combining with carbon to make aluminum and carbon dioxide. We know this one isn't balanced because if we look at it, we've got aluminum, we've got oxygen, we've got carbon, we've got 2, 3, 1, and on the other side we've got aluminum, and that is 1. We've got carbon with a 1, and to make sure we keep them in order, oxygen with a 2. So definitely not balanced, right? The only one that has the same number is the carbon. So let's take a look at how we might be able to balance this. So we've got 2 aluminum, 3 oxygen, 1 carbon. So we know that we need to change the number on the oxygen and the aluminum. So let's change the number on the oxygen. And since we're going to multiply, if we put a 2 here, right, that goes 2 times 3. That gives us 6 oxygen. All right. So if we do that, because the coefficient here is assumed to be 1, and so that's why I went ahead and I just did 2, just to see what would happen. So if we got 6 here, what can we do to the other side to get 6? If we put a 3 here, that now gets us 3 times 2. That gets us our 6 oxygen. But that changed things, right? Because now instead of 1 carbon, we now have 3 carbon. And over here, instead of 2 aluminum, we have 4. So aluminum and carbon are by themselves, so we just need to make adjustments to their numbers. So if we have 3 carbon on this side, then we just need to put a 3 in front of this carbon, because that'll be 3 times the 1, right? Because the subscript is 1. So now we have 3. All right, we have 4 aluminum over here. So to get this one to be 4, we just put a 4 in front of it. And now we are balanced out. So let's take a look at what this looks like if we put the atoms in, if we were to draw the atoms. I knew I wasn't going to be good enough to draw, so I did this one with some shapes. All right, so here's the balanced equation, right? So here is our original aluminum oxide, our original 1 carbon, our original 1 aluminum, and our original 1 carbon dioxide. So when we started balancing it, we made it 2 aluminum oxides, right? But that means that we needed to balance things out. So this time when I did it, I decided to balance the aluminum first. So 4 aluminum. Then, okay, that's done, but we still needed to fix the oxygen. So put the 3 in. Now we have the 3 carbon dioxide, and need to fix the 3 carbon because there's 3 carbons here. That gives us the 3 carbons on that side. All right. So here is a question for you. So is this balanced? And you should be able to answer that one because this is actually the chemical equation that we just looked at a little bit ago in this video. This is the methane, oxygen, water, carbon dioxide equation. And the answer is yes, right? The same atoms appear before and after the arrow, right? We've got the same number of them. Now in this one, you can see that they went ahead and put the 1s in, and you'll see that sometimes show up on problems where they'll put the 1s in. You'll also see this show up, for example, if I have a multiple choice problem where I've asked you to balance an equation, because I can't just leave blanks. So if this was, I had the blanks for the coefficients and I gave you an answer, it would be 1, 2, 2, 1 would be the balance to put in for the coefficients for this equation. That way there wouldn't just be open blanks in the equation. All right. I will post another video just with some other practice problems. So if you want to see some more practice, you can watch that one. Otherwise, you can move to the next video.